ESCAPADE is a twin spacecraft interplanetary mission to orbit Mars to understand Mars's unique magnetosphere. This is the first ever twin satellite mission sent to Mars. Berkeley has been involved with Mars missions since the early 1990s, with the Mars Global Surveyor mission and the MAVEN mission in 2013, and then ESCAPADE is sort of the next logical step. The two spacecraft are named Blue and Gold. The ESCAPADE spacecraft are going to launch to Mars on the Blue Origin New Glenn rocket this fall.
We know that Mars once had a warm and wet atmosphere. It was definitely thick enough that liquid water could exist on the surface. But we know also today that Mars has a very thin atmosphere that would never be able to support liquid water. So ESCAPADE is going to help us understand how Mars lost its atmosphere. ESCAPADE will provide us with direct measurements of the escaping particles that are leaving the planet today to be lost to space.
Because the interaction of the solar wind with the magnetosphere and the upper atmosphere of Mars is so complex, if you only have one spacecraft, you can either be measuring the effect of the interaction of the solar wind, or you can measure the solar wind, but you can't measure both at the same time.
ESCAPADE allows us to be in two places at once and to simultaneously measure the cause and the effect. ESCAPADE has two instruments measuring electrons and ions that are built right here at UC Berkeley.
On ESCAPADE, the electrostatic analyzer exploits kind of a cool feature of electrons in space. Electrons of a particular energy tend to flow along magnetic field lines, and the way they're flowing along magnetic field lines can actually tell you what that magnetic field is connected to. You can tell something about the state of the plasma, the state of the atmosphere, the state of the sun from far away by measuring something really close.
The upcoming ESCAPADE mission will be our first mission that is truly interplanetary. Because it's going to be the first time we operate spacecraft that far away from Earth, it's going to be unique for the first time for us to know that we can't have real-time information into what's happening in the spacecraft. We are simulating and training by putting in light travel time delays into our mission simulations. We will be the only entity other than the Jet Propulsion Laboratory in Pasadena that will be operating spacecraft in low Earth orbit, around a Lagrange point, around the Moon, and at Mars.
We need to understand the system well enough to send astronauts safely to Mars. A very important thing to understand is how radio signals propagate within and through Mars's atmosphere. That's important for communication and navigation signals. It's very exciting now to see the hard work of so many people converging towards this moment of launch this fall.